Okay, y'all, this is my first lesson, and I don't know how it's going to go. But, okay, so this is what we'll be doing moving forward. Hopefully, if this works well, what I will do is well, I know you're sad, but I'm abandoning Springboard. And I'm going to use more of a paper-based curriculum that I've used in the past. I just feel like you guys will be more successful that way. So you'll notice that we're going to kind of review. I know that you are expecting us to have a quiz, but with me being out those last days and then with all of this craziness, I kind of want us to just kind of go back a little bit, review these logarithms, make sure that you understand them, give you guys an opportunity to ask questions, and then we will have a quiz. So I'm hoping that we will have a quiz by the end of this week, possibly on Friday, and if not, then it will be after your spring break. We will still be taking spring break. Next week we won't have any assignments over spring break, and then we'll just be coming back. So I hope that this works well. I did do a Zoom, which is kind of like a conference call with some of you students today, some of you guys. So we might possibly do that in like preps for a quiz or a test, like let you guys ask questions. So anyways, here we go. I'm going to get started with this. This notes page is something that you can print off at home, or you can just watch me work these, and then your homework assignment is there as well. So if you have a printer at home and you want to print these things, you can. If not, you can just use loose leaf sheets of paper and write whatever you want to write to keep up with this, to make sure you are able to do that. Same thing with the homework. I'm going to try to enter it in as something where you're typing the answers, so like you could do your scratch work on your own loose leaf sheets of paper and then just submit your answers done digitally. I don't know that I'll have that all organized this week, but hopefully I will be able to get all of that done soon. You can see I brought my Elmo home with me, and I will try, what I'm going to try to do is probably record the lessons after my children have gone to sleep, and then post them first thing the next morning, and then make the homework due the next day at like 10 o'clock in the morning. So you're going to have to wake up and like do your stuff, or either stay up all night and do it, whatever works for you. Okay, alright, so here we go. We are talking about logarithms still, and it says here a logarithm is another way to write exponents. It's what we've been talking about this whole time. So here's your logarithmic form. Log, there's your b, a equals x. So it's read log base of a equals x. And the way that I said it to y'all was log, then you have the base, your answer, and it equals the exponent. That allows us to write it in exponential form. So if we change this to exponential form, you would have your b there. That is your base. The exponent is x, and it equals a. So you have your base to the x power, and it equals a. Basically, when you're doing this, the logarithm equals the exponent. So you've got your logarithm, and it's going to equal the exponent. Okay. So here we are, we're just going to be doing some converting. So it wants you to write each equation as an exponential or in exponential form. So log base 3, 9 equals 2. So the base of this one is 3, the exponent is 2, and it equals 9, which is a true statement. 3 to the second power equals 9, so that makes perfect sense. Same thing with this one. It's log base answer equals exponent. So your base is 6, exponent is 3, and it equals 216. I'm just going to do these real quick so that you can see me do those Remember that when your exponent is negative, you can't see that. When your exponent is negative, like number 5, that's when you get your fraction. 4 to the second power is 16, but because it's negative, it's 1/16. And this one would be 9 to the 3/2 power, and that equals 27. Okay, so that's your converting from log to exponent. At the bottom of this page, we're going to be doing just the opposite of that. So this is the base, this is the exponent, and that is your answer. So you're going to say log subscript 14, your base is in the bottom. The answer is 196, and it equals 2. Log 14, 196 equals 2. This one would be log base 3, 81 equals the exponent, which is 4. So the logarithm equals the exponent. The subscript is your base. The large number is the answer. So again, I'll do these quickly. The fractions might be some that you may not have really thought about having a base to a fraction, but it works just the same. So, and you'll have a calculator because you're at your house, so there's no reason not to do it in your calculator, but it works just the same way. Okay, so second page of your notes. Now, this is all about the common log, which is what we've talked about. Common log is when you have a base of 10. And that's the one that's on your calculator that you don't have to press a button for. Like it's just log 10. The one on your cell phone is log 10. That's your common base. So it says a logarithm with base 10 is called common logarithm and can be written without the base. So log 10x is just written log x. So you don't have to have that subscript 10. It's just understood to be there. Now, this is when they are evaluating the logarithm. So you have a logarithm, and what you're looking for is the exponent. This logarithm, I want to know what's the exponent. Well, you're looking for the exponent that goes with the base. The base of this one is 7. 7 to the x power equals 49. Well, you're trying to figure out what power you would raise that to get 49. So x equals 2. Okay, for this one, you've got log 3, so 3 is your base to the unknown power, and it equals 27. So 3 to what power equals 27? I got to get my calculator so I don't do this wrong. Y'all aren't here to give me the answers. So 3 to the third, I believe. Yes. 3 to the third. And can y'all even see that? No, but it doesn't matter. 3 to the third gives you 27. So that's going to be my exponent. For this one, there's not a subscript there, so that means it's common log. That means it's the base 10. I'm looking for the exponent that would give me 100. The log is looking for the exponent, so that's going to be 2. All right, the next one, 12 is my base. I don't know the exponent, but I know it equals 1. Well, this is one that you're just going to have to memorize. Anything to the 0 power equals 1. Anything. So since we have 12 to some power and it equals 1, that some power has to be 0. And that's your answer. Anything to the 0 power is 1 always. Okay? 2 to the x power equals 64. Okay? Again, I think that this is 5, but I want to double check. 2 to the 5th power is 32. See, I'm wrong. So 2 to the 6th power is 64. Okay, so I'm just using my calculator to help me get that, plugging in some exponents to see which one gives me a true statement. 3 to the x power equals 243. X is going to be, see, this is where I need my smart people in my class to help me with this. Let's see, why is it so not letting y'all see that. Does that help a little bit? Yeah. Okay, cool. I don't know. Oh, I think you can turn the brightness of this down too. Like a cell phone. What? Look out. That's too dark. Okay. So we're looking for an exponent here. I think it's 4. It's not. It's 5. Okay, so 5 is the one that we're looking for, so that's going to be x to the 5th. All right, then we have 9 to some power equals 1 over 81. Okay, so since this one is a fraction, I'm really just thinking about the 81. 9 to what power gives you 81? Well, that would be 9 to the 2nd. 9 to the 2nd gives me 81. So, because it's a fraction right here, I know that means that exponent is a negative 2. Okay? And then for this one, we have 64 to some power equals 4. Now, one way that you can do this is you can think about 4 as your base and convert this to base 4, because we found earlier, or actually not, convert both of them to base 2, because 64 could be raised to the 2nd, or a number 2 could be raised to a power to give you 64. Same thing with 4. 2 can be raised to a power to give you 4. So doing that and giving them a common base is going to allow you to solve for that, because it's going to be a fraction. And some of you can look at it and figure out what it is or guess, but for those of us that can't do that, I'm going to make them have a common base. 2 to the 2nd power equals 4. So those are congruent. I can set those equal to each other. Then we learned up here on this one that 2 to the 6th power equals 64. So I'm going to put a 6 here. That's going to be congruent to 64, and I put an x right beside it. Because there was x here, there's an x here. I can't change the statement, but what I'm doing is I'm giving them the same base. Now, because they have the same base, I can cancel out those 2's just like that, and then say 6x equals 2. Set my exponents equal to each other. Solve for x. I divide by 6, so x equals 1/3. So my answer is 1/3. 64 to the 1/3 power gives me 4. So your answer is 1/3. Okay, I'm almost done. I'm going to try to keep my lectures under 20 minutes, shorter if I can, because I know that you don't want to spend a solid 2 hours, 3 hours on math class every day. So I want to be able to have my lecture and then also your homework assignment to be something that you can do under the same amount of time you would be in my class, which is 54 minutes. So we'll see if I can do that for us. Okay, and then this one is change of base. We have not talked about this yet, guys, but this is a way that you can do this when you don't have a calculator that allows you to change the base. These obviously do, and I'm sure some of you found that out when I was away, you like Googled how to do it in your graphing calculator. If you do have one of these, you would go to math. I believe it's under math. I might be wrong. Yeah. If you go under math, you can see this log base right here. If you press that, it allows you to type in whatever base you want. But if you don't own one of these calculators, your calculator probably just has common log on it. So common log is base 10. Well, when you have a situation like this where you have a base that's not 10 and you don't have a fancy calculator, you can use what's called the change of base formula. What you do is you just take common log of A, the big number goes on top, over common log B on the bottom. So you're taking whatever the answer is, you're pairing it with common log, and then you're dividing it by common log of whatever B is. Let me show you what I mean. So if we look at this one, we take log 64 and we divide that by log 16. Now that's something that you can type into any calculator. Let's get my cell phone for example. Alright, so